the University of St. LaSalle College of Arts and Sciences Mathematics Department. Now here we will be uploading a playlist, a set of videos which we'll call Algebra 101, which is a typical type for an introductory course for everyone to understand a particular subject area. So here we'll present algebra, okay, in a sort of a lecture notes way. So we're going to present it in the most friendly way, shall we say. Well, this is to remind you of the basic algebra and pre-algebra topics that you'll need in your future course. Okay, so we'll start with the root of them all. This will be the real number system. Okay, so the real number system is very important. This is the number system that is used in algebra. Okay, remember in your arithmetic, you only use positive numbers with the zero. So this time, we'll use beyond. What's beyond of it? So let's review the types of numbers that make up the real number system. So we'll start with number 1. That's the natural numbers, also known as the counting numbers or the positive integers. Okay, let's talk integers. Let's talk about integers later on. So this is, since we learned how to count first, so of course we'll start with this. So this is their natural numbers, denoted by this double script n, okay, which stands for n, of course, natural. So natural numbers are these, okay, also known as counting numbers again. So 1, 2, 3, 4 up until positive infinity going to the right side. Okay, so second is in our arithmetic we lack something here. What is beside 1? So that's the number for nothingness, that's 0. If we're going to add 0 on the list, we call that the whole numbers. So this is whole numbers, the n, which is your natural number here, union your 0. So we're just going to add 0 with your natural numbers, we call that your whole numbers. So this is the list of the whole numbers then. Okay, so next is, well, for every positive integer, this is a belief, or shall we say an axiom in the real number system. Every positive integer, there exists a negative integer also, which which lies here on the left side of our line. Okay, we call those integers if we're going to add the negative numbers now. Okay, so these are all integers actually. So the integers are denoted by z. That's the double script z. Why is it z? Why not I? Okay, because Z stands for Zahlen. Zahlen is a German word for numbers. Maybe because George Cantor, the one who made this. Okay, is it because he's German? George Cantor is German, so maybe that's the reason why it is Z here. So Z integers is equal to your negative integers Z, Z minus. Okay, that's why it's here. Union 0 union n. So this actually, your 0 union n is just your whole numbers. So your whole numbers plus the negative integers will be the whole set of integers. Okay, next here, in division, when we divide numbers, seldom we have a result which is not a whole number or which is not an integer. Seldom we have results like negative 1/2, 1/2, 3/2, 4/3, and so on. So where do we put those numbers? So we're going to add here. So we know that negative 1/2 is between negative 1 and 0. 1/2 is between 0 and 1. 3/2 or 1 and 1/2 is between 1 and 2, and so on. So we're going to create another list. We call that rational numbers. Okay, those are the numbers denoted by Q, because which stands for quotient, because we're dividing them. And then rational numbers, it's not that it's rational or thinking, it's from the word ratio. Okay, again, if we're going to think of ratio, 1:2 is just say equivalent with 1/2. So we're still dividing. So quotient, your Q, your rational numbers, is just equal to your Z, your Z, your integers, union, and your as I shouldn't read this as and positive integers, or your integers rather, or your integers prime. So we call that your non-integers. Your non-integers are the one you cannot put on a whole number, but they are fractions. So if we're going to put them on a single line, all of them are rational numbers. Okay, so all of them are rational numbers. So a rational number is one which can be written in the form of 1/2, 3/2, okay, negative 1/2, or we could generalize that as a over b, wherein a and b are both integers. Imagine a and b here, 1 and 2, they're both integers, and b must not be equal to 0. So we cannot have a 0 in the denominator. So because if we do, that will not be, well, that's not good for us. That's not good for our health to have a denominator of 0. So let's erase the denominator with 0 in the rational numbers. Okay, so anyways, if you have a rational number in decimal format, of course, we can put this 1/2 into 0.5. If it is in decimal format, the decimals must be terminating or repeating. Okay, so imagine this 1/2 is 0.5. It terminates. Okay, we don't have any number, okay, on the right of it, so it's only 0.5. But you can imagine 1/3, 1/3. So if we're going to write that in a decimal representation, that's going to be 0.333333. Okay, it's not terminating, but then it's repeating. Okay, so those are rational numbers in decimal representation. Next in our list is the irrational numbers, or are the irrational numbers. Okay, they were first introduced when you have a triangle with sides 1 and 1, a right triangle, and you solve the hypotenuse where the answer is square root of 2. So what is the square root of 2? That's an irrational number. So okay, so irrational numbers are denoted by q, but not q, though q prime. Okay, q complement rather. So this is z complement, not integers. So this is a q complement, not rational number. So that's why it's irrational. All square roots or any root which is not perfect, not a perfect root, are all irrational numbers, including these special constants. The pi. Okay, so pi is 3.14 something something something, so it's between 3 to 4. You have your Euler's number, your e, which is 2.718 something something something, so it's between 2 to 3. So that's e. Pi, we can have negative e here on the other side, you can have negative pi on the other side, and so on. So you can have negative irrational numbers also. But the thing is, they're irrational. In short, when you say irrational, they could not be put in a ratio. Okay, so they cannot be put in a form of a over b, where a and b are integers, so they cannot be put in a fractional form. Okay, and their decimal form are always non-terminating or non-repeating. Okay, notice this pi here. If we're going to go on a number of digits, it's 3.14 something something something. Okay, wherein if we're going to move on, write all the digits, it's not terminating and it's not repeating also. Same also with this e, 2.71828 something something something, it will not repeat. Okay, because that's the definition of an irrational number. The numbers in the right hand side, on the right side of the decimal point, will not repeat. So that's irrational numbers, and they cannot be put as a fraction from the word irrational. Okay, so if we're going to combine all of these numbers here, all these sets of numbers here, okay, this will compose or comprise a collection of numbers, or a system of numbers. We call that now the real numbers, denoted by r, okay, double script r. That is, you combine your q, your rational numbers, or your irrational numbers, your q complement. These are all real numbers. Okay, so this will be the set of numbers, the system that will be dealing with algebra, and also in higher mathematics, okay, calculus. We will use all these concepts. So the strong background with this concept is very important in the field of algebra, calculus, trigonometry, and so on and so forth. Anyways, just to note, this is not the last part of the real number system. We can have complex numbers after this if you're going to combine r with I, your imaginary number, and you can have quaternions after that, octonions, and so on and so forth. Okay, the lower we go, the less applications, the less we can apply it in our real world. Okay, so that's our real number system. If you want it in a diagram form, so we can see it here. So we start with natural numbers. Okay, here we combine it with 0, we have whole numbers. Whole numbers divided with negative integers, we can see it here. 0, and these are whole numbers. Combined with negative integers, we have the integers. Integers with combined with fractions, this is your z complement. These are fractions, the non-integers. So fractions plus integers are called irrational numbers. We can see it here, and we have an irrational number on the right side. There's nothing below that. But if you combine the rational numbers and the irrational numbers, we'll have the real numbers. So this is it. So these are all the collection of it, of our real number system. Okay, so that's it. Hope you're enlightened by this video here, and we'll be posting more. Okay, so stay tuned. Like our Facebook page is written here, and don't forget to subscribe. Thanks.